Let's look at the solutions of number system bytes for this day. What is the least natural number that will leave a non-zero remainder when it divides 23 factorial? So see, we are looking for the least natural number, which when it divides 23 factorial, we get a non-zero remainder. Basically, 23 factorial should not be divisible by this n. Hopefully, you can see any number lower than 23, it will definitely divide. So that is not useful. We have to look at n greater than 23. So the first case you can see is 23 factorial by 24, but 24 will break down into 8 into 3, and that is definitely contained within 23 factorial. So this is not ideal. Similarly, when you have 23 factorial by 25, this breaks down into two fives, and 5, 1 into 2 into 3 into 4 into 5 and 10 and 15 and 20, you get fives there. Can you see, as long as you keep dividing it by composite numbers, your purpose will not be served. So check the next prime number. The next prime number after 23 is 29. This divided by 29. This will definitely not be divisible. And therefore, the answer to the question is 29. Next is find the remainder when 7 raised to the power 13 minus 13 raised to the power 7 is divided by 91. Okay. So we've got 7 raised to the power 13 divided by 91 minus 13 raised to the power 7 divided by 91. I'm writing them separately. I'll find out remainder in the first case. I'll find out the remainder in the second case, and then we can reach our answer. I know numerator and denominator both have 7 in common here. So we take that out. Now we are left with 7 raised to the power 12 divided by 13 here. And here we see numerator and denominator both have 13 in common. So we take that out. So we now have 13 raised to the power 6 divided by 7. The Fermat number for 13 is 12. The Fermat number for 7 is 6. So basically, remainder in both these cases, the portions within the bracket, you are going to get remainder 1. So this first term turns to 7 by 91. And the second term turns to 13 by 91. Or altogether, you are getting a remainder of minus 6 by 91. A remainder of minus 6 by 91 is as good as remainder of 85 by 91. So answer to the question has to be option B. Another way you could potentially have progressed here was, given that we are finding out remainder with 91, that why is my pen not working? Given that we are finding out remainder with 91, effectively we are looking for remainder with 7 and 13. So the first part is definitely divisible by 7. So I can write minus 13 raised to the power 7 divided by 7 is as good as, how much more do you need? This is minus 13 is as good as minus 1. It leaves a remainder of minus 1 with 7. So minus 1 raised to the power, sorry, it leaves a remainder of 1, no? If I add minus 1, this is becoming so difficult to process. Wait. 13 raised to the power 7 minus 13 raised to the power 7, which is as good as by 7, which is as good as minus 6 raised to the power 7 or 1 raised to the power 7 by 7. So remainder with 7 will of course be 1. This much we know. Secondly, what we have is, this is me trying to find out remainder with 7. So we know family wise we have to get 7 and plus 1. Then we have 7 raised to the power 13 divided by 13. I'm only doing 7 raised to the power 13 divided by 13 because this portion, if I need remainder with 91, I need remainder with 7 and 13. Remainder with 7 I have obtained. I got that. Remainder with 13, if I need, the second part is anyway divisible by 13. So here I can remove 12s. So I get 13k plus 7. If I combine these two, I will still reach the same result, 85. In either case, answer will be 85. There are two ways of approaching it. Next, a number has 10 factors, 5 of which are even. If the sum of all factors of the number n is 2801 less, sorry, sum of all the odd factors of the number n is 2801 less than the sum of all its even factors, then what is the sum of all the factors of n? Okay. First, look at this n. It has 10 factors. It has 10 factors. So there are only two ways in which a number can have 10 factors. Either it is a what is it? Either it is a prime number raised to the power 9, or it is some prime number raised to the power 1 into some prime number raised to the power 4. In both these cases, you end up with 10 factors. If it was prime number raised to the power 9, if it was a singular prime number raised to the power 9, then can you see all the factors that you obtain, apart from the first one, apart from 1 as a factor, all the factors that you obtain, either they will be even or they will be odd. Basically, you can have two cases. Just see, let's say it was 2 raised to the power 9 or 3 raised to the power 9. Here, there are 10 factors, of which 9 are even, 1 is odd. Here you have all 10 odd factors. All 10 will be odd factors, and therefore this is not the case of n. This is not the way n would have been. Now we've got this. Given that 5 factors are even, one of these two has to be even. So let's say 3 raised to the power 1 into 2 raised to the power 4 we were doing. 3 raised to the power 1 into 2 raised to the power 4 we were doing. How many odd, how many even? Can you see? There are 2 odd and 8 even factors here. The only odd factors here are 1 and 3. Every other factor would be even, and therefore this is also not acceptable. Why does my pen go into sleep mode? This will also not be acceptable. The only acceptable case would be when I have 2 raised to the power 1 into some prime number raised to the power 4. This 3 here was for example purposes, not that 3 is definitely involved, was for example purpose. In this case, can you see p will be an odd number? Any odd number apart from 2 will necessarily be, any prime number apart from 2 will necessarily be an odd number. So the factors here, you will have, let's say, 1 into 2p raised to the power 4. Next, you will have 2 into p raised to the power 4. Then you will have p into 2p cube. Then you will have 2p into p cube. Then you will have 2p square into p square. These are the 10 factors, of which this one here, this one here, this one here, this one here, this one here will all be odd. The ones that are underlined are odd. The other ones are not odd. Now the question goes into sum of its even factors. Now sum of all factors of this number will be given by 2 raised to the power 0 plus 2 raised to the power 1 into p raised to the power 0 plus p raised to the power 1 plus p raised to the power 2 plus p raised to the power 3 plus p raised to the power 4. This is sum of all factors. Now this is sum of all factors. Sum of even factors will be equal to 2 raised to the power 1 into p raised to the power 0 plus p raised to the power 1 plus p raised to the power 2 plus p raised to the power 3 plus p raised to the power 4. And sum of its odd factors will be given by 2 raised to the power 0 into p raised to the power 0 plus p raised to the power 1 plus, why is my pen not working? Okay, p raised to the power 2 plus p raised to the power 3 plus p raised to the power 4. So when we are told if the sum of all the odd factors of the number n is 2801 less than sum of all its even factors, basically if this is m and this is n, m minus n, this minus this is equal to 2801. 2 times this bracket minus this bracket is equal to this, or essentially what we have been told is p raised to the power 0 plus p raised to the power 1 plus p raised to the power 2 plus p raised to the power 3 plus p raised to the power 4. This is equal to 2801. Now, if you want to find out the value of t, of course, you can go ahead and find out 2801 by plugging in values. You will reach the value of t is 7. You get 1 from here, 7 from here, 49 from here, 343 from here, and 2401 from here. 56. Yes, you will get 2801 from this. You can plug in, but can you see the final question was simply sum of all factors? We know it is 1 plus 2, 3 into this bracket. As soon as you arrive at this result, you can get your final answer 2801 into 3, or your final answer in this case will be 8403. Sum of all factors of n is 8403. In case you want to identify what precisely n is 2 into, so this will be 4802. This is the number. This is the actual number, and sum of all its factor is 8403. 8403. This is the answer. The number n is 4802. 7 raised to the power 4, which is 2401 into 2. Okay. What is the least positive integer with which 290 factorial should be multiplied so that it is divisible by 48 raised to the power 72? Break this down. 48 raised to the power 72. So we get 3 raised to the power 72 into 2 raised to the power 4 into 72. So 288. So let's find out how many 2's are present within 290 factorial. The process is fairly simple. 290 by 2, 145 by 2, 72 by 2, 36 by 2, 18 by 2, 9 by 2, 4 by 2, 2 by 2, and 1. So these three add up to 7. These add up to 9 into 7. So 63. And these add up to 217. So 70 plus 217, 290 factorial definitely has 2 raised to the power 287. Let us also do the same processing for 3. So 290 by 3 gives me 96. At this time only I can stop, because all I needed was 72 powers of 3. I have already got 96 powers of 3. So 3's are not limited. What is limited? 3 raised to the power 96 plus. I don't even want to care what precise value I will reach. Something higher than 76. Sorry, something higher than 96. So if I want 290 factorial to be completely divisible by this expression, all I need to multiply it by one single 2 is missing. All I need to multiply it by is 2. Last question. If 8 raised to the power x minus 4 plus y is equal to 2 raised to the power 2x into 2 raised to the power y into 2 raised to the power x plus 2y minus x minus 504, then find blah, blah, blah. Okay. Ideally, how this should be written down is, see, 2 raised to the power 2x, I'm writing down the right expression, plus y plus x plus 2y. So 2 raised to the power 3x plus 3y minus 6 minus 2 raised to the power, this is 2 raised to the power 3. So 3x minus 12 minus, plus 3y is equal to 504. I've taken 504 to the other side and brought this expression to this side. So let me rearrange it even better. Three x plus 3y minus 12. So now see, very simple idea, Can you see this is 2 raised to the power a, something 2 raised to the power a minus 2 raised to the power b is equal to 504. This is what we have reached. Between a and b, of course, b is smaller. So if I take out b common, I'll be left with 2 raised to the power a minus b minus 1 is equal to, and now break this up into prime numbers. Will we get this? 8 into 63, or even this 63, can we write it as 2 cube into 2 raised to the power 6 minus 1. This is what, look at the expression on the LHS, look at the expression on the RHS. Can you see B is 3, and A is 9, B is 3 or A is 9. So we now have precise value for these expressions also. So 3x plus 3y is minus 6 is equal to 9, or 3x plus 3y is equal to 15, or x plus y is equal to 5. Finally, what the question asked me was x plus y only. So x plus y is equal to 5. Our work is done. We are not concerned with what is the precise value of x. We are not concerned with what is the precise value of y. Even if we had replaced it here, we would have gotten the same result. The result is immaterial whether you place it in the first expression or the second expression. Hopefully you learned something. That will be all. Okay, bye people.